Hello, this is a key to the first content checkpoint for the constant velocity particle model. So to start off with, there's a list of things here that you should be familiar with. Make sure that you read through this and that you understand everything on this list. So it's things like knowing the difference between distance traveled and displacement, or velocity and speed. And they're all kind of subtle differences, and so by the time you take this first quiz, I want you to have clarity on these different definitions and be able to apply them when you need to apply them. So if you have any questions about any of them, make sure that you ask me in class. But these are the definitions that you need to know for the first quiz that we have here. So in this first section here, what we've got is we've got a situation where there's a car and it's traveling from town A to town B to town C. And I'm asking you some different things using these terms that are listed above. And so again, you need to know what the different terms are so that you can answer the questions. So for instance, question number 1, it says describe the position of town B relative to town A. Well, you should know that position is a vector, so we need a distance and a direction. Up in the problem, I listed the direction as 9 degrees south of east. All right, so that's just right in the description of above. You just have to pull it out. So so it is 9 degrees, it is 20 miles away. At 9 degrees south of east. Or you could have said in the direction of 9 degrees south of east. Alrighty, number 2, what's the displacement resulting in the entire trip A to B to C? So if we're going displacement here, displacement I said is not path dependent, meaning that we don't care the way that we've traveled, we just care where we started and where we end up. So what we're looking at here is we're comparing A to C essentially. And so your displacement here is going to be just 6 miles south. Remember, displacement is a vector, so we need a magnitude in a direction or a distance in a direction there. So it is 6 miles south. For total distance traveled, we look at the odometer reading. So if you turn on the odometer in this car, it would go 20 miles to B and then another 20 miles to C. So the entire distance traveled, total distance traveled, is going to be 40 miles. And you don't need a direction with that because distance traveled does not have a direction. All right, the speed is the car travels from B to C. So to calculate the speed, you do distance traveled over time, all right, which in this case is equal to 20 miles in 40 minutes, which equals 0.5 miles per minute. The velocity is similar, but we need a direction associated with it. You know, generally speaking, if you're on a number line, you could think positive or negative, but in this case, we're going to just say what direction we're going if we're going from B to C. So our velocity here is going to have that same 0.5 meters per second. All right, but it's going to be in the direction that we're going from B to C, which is 9 degrees south of west. All right, so velocity, you need the speed there, but you also need the direction that it's going in. Sometimes if we're talking about a number line, that will just be positive or negative, but since this one is talking about map directions or like the cardinal directions, that's where we get the south of west in there. Alrighty. Down here in the bottom, it's asking for the average speed and the average velocity. So average speed, which we can denote with like an S with a bar above it, average speed, again, equals the total distance traveled over the time. Alright, which in this case equals, if we're looking at A to B to C, the total distance traveled is 40 miles. Alright. And the amount of time it took was 60 minutes. Alright, so 40 over 60 gives you 0.67 miles per minute. Alright, that's your average speed. Now your average velocity, we're looking at the displacement over time, alright, which is delta x over delta t, or you could say x final minus x initial over t, alright, which in this case, if you're just comparing A and C, because we don't care about the path for displacement, we said that it is 6 miles south, alright, and the time it took was 60 minutes, alright, and so that's 0.1 miles per minute. And since it's a velocity here, we need a direction, so south. Alright, and that's what we've got there. Okay, again, as I said, there are a lot of different terms here, and it's important that you know the difference between the terms, and it's important that you know which one's a vector and which one's a scalar, so that you know which ones need directions associated with them and all of those things. So just, you know, really, really try hard to understand these concepts, and as I said, if you have questions, come and ask me about that. Moving on to the back here, we have a set of problems where we have these different representations of motion. So in the first one, I've given you a written description, and you need to make it into these other things. So the first one, it says here, it starts with a position of 2. I'll just make the motion map. So if it starts with a position of 2, the first dot goes here at 2. All right, and it says it travels with a velocity of negative 2 meters per second for 3 seconds. All right, so there's 1 second, 2 seconds, 3 seconds. All right, and then it says it stopped for 2 seconds. All right, so that first one without an arrow, second one without an arrow, and then we're going to go here. And then it reverses direction and is going to be going 5 meters per second for 2 seconds. So we count up 5, and it gets us here. And then we count another 5. Gets us here. Right, and then just fill in the arrows. So going 2 meters per second here, negative 2 meters per second. And then it stopped for 2 seconds. And it travels at 5 meters per second this way. No arrow on your last dot, and that's it. I'm just going to darken my dots so that it's really clear where they're at. That'd probably be a good practice for you as well. Okay, so on to the position versus time graph, I think is the easiest next one to do. So it just follows exactly the same points in time. So I'll just mark this up. We'll go 1, 2, 3, 4, 5, 6, 7, 8. It's not going to go up that high. And down on the bottom, 1, 2, 3, 4, 5, 6, 7, 8 down. All right, and then I'll just mark the spots here. So it starts off at at positive 2 at time 0. All right, then the next second it's at 0. All right, and then the next second it's at negative 2. And then the next second it's at negative 4. And then it stays there for 2 seconds. All right, and then in the next second, we are up at a position of +1. And then in the next second, we're at a position of 6. All right, so it looks something like this. All right. For the velocity versus time graph, what we're going to do is we're going to try and line it up here. So in that first period, we were traveling with a velocity of -2. So that's going to be for 3 seconds. As I said, try and line it up on the bottom. Then for 2 seconds, we're stopped. And then for 2 seconds, we're at a velocity of +5. All right. And so that's how that would look. All right, going down to this next one, this is pretty complicated, all right? So leave yourself some room to write here. So it starts off, it has an initial position 0, okay? An object has an initial position of 0. All right, then we need to see where it's going and how fast. So it jumps up there to 4. So it's going to travel with a velocity. It travels with a velocity of 4 meters per second for 1 second. And then you can see there it stops for a second. All right, then it's for 2 seconds it's traveling with a velocity of -3 meters per second. For 2 seconds. Then it abruptly changes direction here. There's not a dot on top of another dot, and it travels with a velocity of +6 meters per second for 1 second. Meters per second for 1 second. All right, that was a long one. And then going over here to the position versus time graph, what we'll have, again, you just mark it off. We'll do like 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And then we're going to mark the positions. At time 0, it's 0. At time 1, it's at, looks like 4 there. At time 2, it stays at 4. At time 3, it is down to 1. here, I'll move that over a little bit. Time 3 is down to 1. All right, at time 4 it is down to -2. All right, and then at time 5 is up to 4 again. All right, so this one looks like this, up and then over and then down and then quickly back up. All right. I'm going to fix this line here. Sorry, it's bothering me. Alrighty. Now for the velocity versus time graph, again, all horizontal lines because velocity versus time graphs are always horizontal. It starts with a velocity of +4 for 1 second. All right, and then it drops down to a velocity of 0 for 1 second. Then for 2 seconds, it's got a velocity of -3. All right, and then for that last second, it's got a velocity of 6. So all the way up here for a second. All right, and it looks something like that. All right, so as I said, this is a pretty challenging problem. Make sure that you feel well versed in doing these. I made them especially challenging just to make sure that, like, if you've gone through this, you've kind of gone through the crucible or the gauntlet or whatever you want to call it, and you should be prepared for what comes up on the quiz. So if you had any trouble understanding any of this, come talk to me. Otherwise, hopefully you'll be in good shape.